Hello everyone, this is Shady Elkassas, Sharjah American International School, and today we are going to have a brief revision for the main requirements of your placement test. Basically, the placement test is one of the requirements of some universities, so you need to have your placement test or placement exam in order to apply for some scientific universities or colleges such as in engineering and medicine. The physics placement exam is having some main points that you need to focus on, and this playlist in my YouTube channel is dedicated only for the physics placement exam, and you will find many videos that can help you to revise and solve most of the problems and the concepts that are included in the placement tests. So the basic concepts of any placement exam are 5 basic topics, and they are first of all the one-dimensional motion, then physics and calculations, two-dimensional motion, which are the projectile motion here, and forces and laws of motion, work and energy. In the one-dimensional motion, you need to be able to calculate the displacement, calculate the velocity, acceleration. You need to apply the basic formulas of the uniform acceleration or constant acceleration, and you need to apply the 4 kinematic equations and to interpret position time graph and velocity time graphs. In the two-dimensional motion, you need to apply the basic equations of projectiles launched horizontally and launched at angles. In physics and calculations, you need to be able to identify the SI units and their types, to be able to convert from a prefix to another, like kilo and milli and micro. You need to use the significant figures in your calculations in multiplication, division, and addition, subtraction. In forces and laws of motion, you need to state the 3 laws of motion. You need to be able to state them and to explain them. You need to be able to define inertia and calculate the net forces and acceleration in different situations. In work and energy, you need to be able to calculate the kinetic and potential energies, the total mechanical energies of any situation. You need to use the conservation law of energies in 2 situations. So these are the basic concepts. In order to summarize this in one map, so let's go to the physics, which is the main root here. The physics is the branch of science that discusses the matter and energy, and it has many branches, as you can see: mechanics, waves, thermodynamics, optics, quantum mechanics, etc. So you have many fields of physics. One of the fields is mechanics, which is our concern today. Mechanics is also classified into main topics, and the main topics of mechanics are the kinematics and the dynamics. The kinematics are the kinematics basically is the branch of mechanics that describes motion, while dynamics is the branch of mechanics that describes the causes of motion. So the one that describes motion, it describes motion through displacement, it describes motion through velocities, it describes motion through accelerations. It describes motion through one-dimensional motion, and it describes motion through the two-dimensional motion. It describes motion through the circular motion. Dynamics is the branch of mechanics that describes the causes of motion through forces, through work, through energy, through power, and through momentum. So mechanics and kinematics and dynamics are the 2 main branches of mechanics. So if we went into the kinematics basically discusses the displacement, velocity, acceleration. The displacement is a delta x or a delta y, it depends on the dimension that you are moving through, like if you're moving horizontally, so delta x is your axis. If you are falling, or you are dealing with free fall motion, or a falling object, or an object that is going upward, so you are dealing with delta y. And the unit is meters or kilometers. It depends on the prefix that you are using. Velocity, which could be the average velocity, it could be initial velocity, it could be final velocity. All of these are terms for the velocity, and each one has a specific situation and a specific term. It is measured in meters per second or kilometers per hour. Acceleration, which is A or G or AG, acceleration in many situations can be described as acceleration A. Specific acceleration, which is the free fall acceleration, is G or AG, which is negative 9.8 meters per second squared. This is also an example of acceleration. Dynamics is discussing forces, work, energy, and power. Force is measured in newtons or kilograms meters per second squared. Work is measured in joules or newtons meters. Energy, which is a potential energy or a kinetic energy, both of them is measured in they are measured in joules, and power is measured in watts. So let's go to the kinematics. Kinematics, the first topic in kinematics is the displacement, and displacement, as you can see, could be a delta x or a delta y. It depends on the dimension that you are moving through. So if the car is moving from a 10 meters sign and to a sign that says 20 meters, so the delta x is the change in position from initial x to a final x. So in order to find the delta x in this situation, it is equal to the final minus initial, which is 20 minus 10, which is equal to 10 meters per second to the east. If you're moving from the opposite 22 from this direction to this direction, so it would be 10 minus 20, because the final will be 10 and the 20 would be the initial one, so it would be negative 10 meters per second to the west, which means that it is a vector quantity. It could be positive, it could be negative, it could be to the west, to the east, north, south, right, left. So displacement, which is the change in position, is a vector quantity. The displacement is a delta y if you are moving on the horizontal axis, which is this delta y. If you are falling down or you are throwing an object upward, so your delta y is starting with the yi, which is initial y, and yf, which is the final y. So delta y would be equal to yf minus yi, and also it could be positive or negative, and it should be a vector quantity. So let's move to the average velocity. An average velocity, you can calculate it in two ways. V average is the rate by which the position changes, which means it is a displacement over time, which means you have two physical quantities divided by each other. That's why the unit is a meters per second, because it is here displacement over time, also displacement over time, and the delta y, so meters per second or kilometers per hour. An example, if the same car, the same situation upward here, this same situation, the car is moving from 10 meters sign to a 20 meter sign, but at the same situation there is time here. I have mentioned time. So I have three physical quantities, or let's say two physical quantities. One of them is position, which is initial position and final position, and I have time in here. So delta x divided by delta t would give you the V average, which in this case 20 minus 10 is 10 divided by the time, let's say 2 seconds, so it would be divided by 2, so it is 5 meters per second to the east. It could be also negative if you're moving from 20 to 10, so it can be negative because it is a vector quantity. So velocity also is a vector quantity, just like the displacement. You can calculate the V average using the math the mathematical average. We know that if you have two quantities and you need to get its average, so you add the two quantities divided by 2. If you have three quantities, you add the three quantities divided by 3, and so on. So in calculating the V average, you have two types of velocities, or two situations for velocities. It could be a VI and a VF. So you can add the VI plus the VF divided by 2, you can get the V average. So if I have given you two V's, or two velocities, one of them is 10 meters per second and the other one is 20 meters per second, and I wanted the V average. So if this is a VI and this is a VF, you just add them and divide them by 2, so it is 20, or let's start with the VI. It won't make a difference, but 10 plus 20 divided by 2, so it is 30 divided by 2, which is a 15 meters per second, and this is the V average. So there are two ways that can help you to find the V average. You can use the displacement over time, or you can use the VI plus VF over 2, which is the mathematical average. And this depends on the givens on the problem. So if you have two positions and time, you have to use this. If you have two velocities, you need to use the average, VI plus VF. Now let's move to the acceleration, and acceleration is the rate by which velocity changes. So you need to have two velocities, one of them is a VI, the other one is a VF, and there is time, which is mentioned here, 5 seconds. So the difference between the delta V, which is VF minus VI, divided by time, or the rate by which this velocity changes, this is what we call the acceleration. So in this situation, the acceleration is equal to 150 minus 100 divided by 5. So it is delta V over delta T, which is 150 minus 100 divided by 5, which is 50 divided by 5, which is equal to 10 meters per second square. And the unit here is meters per second square, which is meters per second per second. The vector quantity, it is a vector quantity, which means it should be positive and can be also negative, and you have to mention the direction. Acceleration has a constant value in the free fall. During the free fall, you have a free fall acceleration constant, which is negative 9.8 meters per second square. This is a constant free fall acceleration in vacuum. This is an example of the acceleration. Now let's talk about the special case. And special case here is the constantly or uniformly accelerated object. If the object is moving in constant acceleration or uniform acceleration, so I need to apply one of the four kinematic equations, which are those equations in front of you. And I mean by uniform acceleration, I mean that the object is uniformly or constantly accelerated, such as, let's say that there is a car and this car is having those speeds. So let's say that it is 10 meters per second, and then after 2 seconds it became 20 meters per second, and then after 2 seconds it became 30 meters per second, and then after 2 seconds it became 40 meters per second. So the time interval is 2 seconds. As you can see, the change rate is the same. So 20 minus 10 divided by 2 is 5 meters per second square. 5 meters per second square. This is the acceleration here. Also here it is 5 meters per second square. Also here it would be 5 meters per second square. 40 minus 30 divided by 2. So as you can see, it is a constant acceleration. In this particular case, we apply the four kinematic equations. Also, it can be applied whenever there is a free fall. When there is a free fall motion, or an object is dropped or thrown upward, you need to apply those equations, but you will change the delta x into a delta y, because in free fall we are moving on a vertical axis. So the uniform acceleration, this is a special case for acceleration, so you need to use one of the four kinematic equations. And the question is here, when to use this equation or this equation or this equation or this final equation? What can tell me that this equation is the right one to solve the question? So all what you have to do is to focus on the given and the question. The givens are the values that are given by the question, and the question itself, or the value that you need to find, is this question. So if the givens and the questions, yani the givens values and the question, they don't include acceleration, so you need to use this. So if the acceleration is not mentioned by any means in the problem, in the givens or in the question, you need to use the first one. Here, if the displacement is not mentioned by any means in the givens or the questions, you need to use this one, because as you can see, it doesn't have any displacement. So when the displacement is not mentioned by any means, you need to use this one. If the final velocity is not mentioned in the problem, in the question or in the given, you need to use the third one. And finally, if the time is not mentioned by any means in the question or in the given, you need to use the last one. Let's have an example. A car accelerates uniformly, which means that I have to use one of the four kinematic equations. This is a key word here. It accelerates uniformly from rest, so this gives me an idea that the VI is 0, to a final velocity 18 meters per second, so this is a VF. In 8 seconds, this is delta T. How far? How far means that I need delta X. So as you can see, VI is given, VF is given, delta T is given, and the question is to find the delta X. And then look at what is not mentioned in the problem here. What is not mentioned in the given or the question? Ask yourself this question now. What is not mentioned? Exactly, acceleration. Acceleration is not mentioned here by any means, which means that this equation or this problem just can be solved by the first equation. Delta X is equal to half VI plus VF times delta T, because there is no acceleration in the problem. So this problem can just be solved by this equation, which is delta X is equal to half VI plus VF times delta T, which means it is equal to delta X is equal to half VI is 0, VF is 18, multiplied by delta T, which is 8. Finish your problem and find your answers in meters. So this is an example of a constant acceleration. So you focus on the keyword, which is a uniformly accelerated, which means that you have to use one of the four kinematic equations. You focused on the givens. The VI is a given, the VF is a given, the time is a given, and he needs the delta X. And then you looked at what is not mentioned in the four values. In the givens and the questions, I couldn't find the acceleration, so I have to use the equation that has no acceleration. Now let's solve another one. A pickup truck moving at 31 meters per second, so this is a velocity, must come to a stop. So this means that this is a VI to a stop, which means that this is a VF, which is 0, moves at a distance of delta X, because it is in meters, to avoid hitting a boulder that has fallen onto the road. How much time I need delta T? So what is not mentioned here as well? Also, it is acceleration. Acceleration is not mentioned here by any means, so I need the first equation as well, which is half VI plus VF delta T. VF is 0. Finish your problem, solve for delta T, and you will find your answer. A go-kart accelerating down a hill, which is 2 meters per second square. 2 meters per second square, which means that this is the, yes, this is the, exactly, acceleration. Travels it can travel at 62 meters, which is the displacement, in 7.75 seconds. This is the delta t. What is the initial velocity? I need the vi. At the top, not so official push start, so basically no other givens here. So I have the acceleration, I have the delta x, I have the delta t, and I need the vi. What is not mentioned in this equation or in this problem? Yes, so it is the, very good, it is the vf. Vf is not mentioned here by any means. So I go back to my equations and I find that the third equation has no vf in the question or in a given. So I can use this one to solve my problem, which is delta x is equal to vi delta t plus half a delta t squared. So delta x is 62 is equal to vi delta t, which I need to find. Delta t is given, which is 7.75 plus half a acceleration is 2 times delta t square, 7.75 square. And as you can see, the only unknown is a vi, so solve for vi. So this is also an example. Let's go to this final example. And a rock is dropped off. Once you see these two words, dropped or to throw an object upward, this means that you are dealing with a free fall motion, free fall, which is also one of the constant acceleration problems, which means I have to apply one of the four kinematic equations. So when you find an object that is dropped off or thrown upward or downward, this means that you need to use one of the four kinematic equations as well, with a very small difference, because in the free fall acceleration there are some values that you already know, such as acceleration, for example, is negative 9.8 meters per second squared, and this is a given even if it's not mentioned in the problem. So you know already that the free fall motion is following a constant acceleration. Also, if the object said to be dropped, this means that the vi is 0. When you drop something, this means that you're dropping the object from rest, unless he said that I dropped an object with a certain speed, so there is a vi in this case. But in general, dropped an object, this means that an object is falling from rest. If someone thrown the object, so if you are throwing an object upward, be sure that the vf is 0. Those are some of the givens that sometimes are not mentioned in a problem, but you need to be able to get them yourself from your understanding to the pattern of motion. So the object here is dropped off a cliff, which means that the vi is 0. A cliff which is 115 meters, which is the delta y in this case. How long? This means that I'm asking about delta t to reach the ground. There is another given as well, which is the 9.8 meters per second square, which is the acceleration. So what is not mentioned in this problem? The vi is mentioned, delta y, which is same as delta x, it is the displacement, delta t, and acceleration. What is not mentioned here is vf, so I'm going to use the equation that has no vf, which is the third one. So I can say that delta y is equal to vi delta t plus half 9.8 delta t square. And here we know that vi is 0, so vi delta t is 0. The whole value is 0 because 0 multiplied by anything, it is 0. So delta y is 115 here is equal to half 9.8 delta t square. Here there is something that you have to take care of. Basically, if you mention that the 9.8 negative, so the delta y should be negative, because when you are falling down, delta y is negative. So if you are using a negative 9.8, your delta y should be negative. So if this is negative, this should be negative. Okay, if you're using the value of positive, so use a positive value for the 9.8. And the 9.8 should be given in the placement tests. Is it positive or negative? Okay, so if it's positive, use the delta y as a positive value. So 115 half 9.8, which is 4.9 delta t square. One of the common mistakes in this particular problem that people are always forgetting to put the square on the t. They put it in the equation, but they forget to put it in the problem itself when they are solving it. Divide by 4.9, divide by 4.9, and then get the square root to find the delta t in seconds. So now we solved 4 problems for the constantly accelerated motion. Also, we solved some problems here related to the kinematic, the basic kinematics, velocity and accelerations and displacement. The final part of the kinematics is the projectile, and projectile could be a projectile launched horizontally or a projectile that is launched at an angle. A projectile that is launched horizontally, like a cannon, that is a horizontal cannon like that, and then the ball is going to have a projectile that looks like that. It is launched horizontally. Or if you have an object like a ball is falling from a desk, it is also following a projectile that is launched horizontally. This is what we call delta x, or a range, and this is a delta y, or the height, and the object is moving at a vix, which is initial velocity on x-axis, because this is the only v in this particular part. Launch horizontally, you use 2 equations, one to find the range and one to find the height. Delta x is equal to vix times delta t to find the range. So delta x is equal to vix multiplied by delta t, and the delta y is equal to half 9.8 delta t square. And the same if you have used a delta t 9.8 negative, so you need to make the delta y negative in the problem. If you're not going to use the 9.8 negative, you are going to use it positive, so use the delta y positive. In these problems, in launch horizontally, sometimes you have the delta x, you need to find the delta x, so the vix is given, but you don't have a delta t. So in these problems, let's say that the delta x is not given, and I need it, find the range, and I have given you the vix, but I didn't give you the delta t. You cannot solve this problem unless getting the delta t. That's why you are going to use the second equation to find the delta t. So that's why I have here 2 equations in order to help you to get most of the physical quantities that you need. The second type of projectile is the projectile launched at an angle, like this situation. So the object, or the v itself, is having an angle here, vi. So delta x is equal to vi cosine theta delta t. Here we changed the vix into vi cosine theta, because here the v would be having 2 components, vi cosine theta, and here vi sine theta. So because there is an angle, so there are 2 components of the v. One is here and one is there. So you remove the vix from the delta x, and I put vi cosine theta times delta t. And here I added the whole value of vi sine theta delta t to this equation. As you can see, they have this common part is the same. I have just added this new part, which is vi sine theta delta t. This is an example. A ball rolls off a table with a speed of 3.2 meters per second. Rolls off a table, this means that this is a projectile launched horizontally, delta x. So this is a VIX, which is 3.2 meters per second. And the height is also given, which is 1.5 meters height. He told you that. So what is the table height is, okay, with the speed of the table. Okay, let's say that I need the range, find the range. I need the delta x. So I go directly, this is a projectile launched horizontally. I have two equations. One of them is delta x, the other one is delta y. Delta x is equal to VIX times delta t. The other one is half 9.8 delta t squared. So VIX delta t, I need the range, so logically speaking, I will follow this one. Delta x is equal to VIX, which is 3.2 multiplied by, and then I will not find the delta t to substitute here, so I have to keep it here delta t, and then to find the delta t from this. So the height is 1.5 is equal to half 9.8 delta t squared. So multiply by 2, no, let's say that this is a 4.9 multiplied by delta t squared, this is 1.5, divide by 4.9, divide by 4.9, square root, and find the delta t in seconds, and then substitute here to find the delta x in meters. So these are the basic concepts of the two-dimensional motion. If you have a projectile that is launched at an angle at a speed of 15 meters per second at an angle of 60 degrees, for example, this is delta t, this is the delta x, or the range, delta x. I need the range after 3 seconds, for example. The equation is telling me that delta x is equal to vi cosine theta times delta t. This is a direct question. So vi is 15 meters per second. Okay. Cosine 60 multiplied by 3. Cosine 60 is half. So this is 7.5. Half times 15 is 7.5 multiplied by 3. Get your answer in meters. This is a very direct question to get the delta x using this vi cosine theta delta t. So once you had an angle, this means that you are dealing with a projectile launch at an angle. You need to use the equation that describes the range at an angle. So by now we summarized most of the values here, or most of the ideas related to calculating displacement, calculating velocity, calculating acceleration, using the uniformal acceleration, the four kinematic equations. And here I'm going to make a video for interpreting the time graph and the position time graph and velocity time graph later. We covered this part and this part, calculating the horizontal and vertical horizontal and projectile launch at an angle in the two-dimensional motion. I will make another video inshallah to summarize the remaining ideas here and here, work and energy and forces. You can also check those main ideas in my previous video under also the the same list here in my YouTube channel, which is physics placement test or physics placement exam. There is another video here which is called basic concepts. I have explained some ideas related to forces, work, and energy. I hope that this video was beneficial for you. Please comment if you need any questions, so please post it as a comment, and I hope that it was beneficial for you. Good luck, and I will miss you all, especially for my graduates, grade 12 this year, 2015. Thank you very much.